We'll start in 1 minute. Today and tomorrow we will review for test 2. Today will be the first part, or however much we can get done. And test 2 is on Wednesday. That will be Zoom proctored, and more information about that later. On the first page of the review sheet, we have 4 problems where we solve each system of linear equations. So on the first one on the upper left, I think what I'll do is I'll multiply both sides of the top equation by 3 and multiply every term on both sides of the bottom equation by -2. So multiplying every term on both sides of the top equation by 3, I get 6x plus 27y equals -12. Then multiply every term on both sides of the bottom equation by -2, I get -6x minus 13y equals +14. And when we add these equations, we can get an elimination. Let's see. My middle coefficient is not correct. It should be minus 26. Okay, now when we add these together, the variable x is eliminated, and I get y equals 2. And then to find the x coordinate, I can use any one of the equations. I'll use the top equation. So I have 2x plus 9y. I'll replace y with 2. So 2x plus 18 equals -4. And then subtract 18 from both sides, I get 2x equals -22. And divide both sides by 2, I get x equals -11. So the solution as an ordered pair is the x coordinate is -11 and the y coordinate is +2. For the system on the right, this is all set up to use substitution. The top equation, y equals -2x minus 2. So in the bottom equation, replace y with -2x minus 2. And then we'll do algebra and arithmetic. We get 7x minus 6x minus 6 equals -9, because 3 times -2 is -6. And in the next step, we can do 2 things at once. Simplify 7x minus 6x to get x, and also add 6 to both sides. So we get x equals -3. And then in the very top equation, we can find y if we replace x with -3. So we get y equals -2 times -3 minus 2. or y equals 6 minus 2, which means y equals 4. And so the ordered pair solution, -3 for x and +4 for y. Okay, the next system on the lower left, notice if we leave the top equation the same and divide every term on both sides of the bottom equation by 2. So divide everything on the bottom equation by 2, we get 2x plus y equals 3. And that's exactly the same as the top equation. So if two equations give you the same line, there are infinitely many solutions. This system is called dependent. But here we're just identifying the solutions. Okay, the system of two equations on the lower right. If we multiply every term on both sides of the top equation by 2 and leave the bottom equation the same, we'll get 2x minus 4y equals 10. Leave the bottom equation the same, -2x plus 4y equals 6. And then add those two equations together. We get 0 plus 0 equals 16, or 0 equals 16. That is false, so that means the system has no solution. You can also determine that it has no solution by showing that the two lines have the same slope but different y-intercepts. That means they do not intersect. Okay, problem 2. This one says a boat traveled 12 miles down a river in 3 hours, and it traveled 12 miles up the river in 6 hours. Find the rate of the boat and the rate of the current. So if we let B be the rate of the boat, and let C be the rate of the current, then when the boat goes downstream or down the river, the rate of the boat will be B plus C. We're using rate times time equals distance. So the rate of the boat going downstream is B plus C, and we're told that in 3 hours it can travel 12 miles. And then when it travels upstream or against the current, the boat will be traveling B minus C miles per hour. And it travels 12 miles in 6 hours going downstream, or going upstream. Okay, so here's our system. One thing we can do, in the top equation, we can divide both sides by 3, and we get B plus C equals 4. On the bottom equation, we can divide both sides by 6, and we get B minus C equals 2. And when we add the two equations, B plus B is 2B, C plus -C is 0, 4 plus 2 is 6. Divide both sides by 2, we get B equals 3. So the rate of the boat is 3 miles per hour. And we can use either one of those equations. Pick one and replace B with 3 and solve for C. So I'll use the top equation. So we have 3 plus C equals 4, so C equals 1 mile per hour. Okay, so the rate of the boat is 3 miles per hour in still water, and the rate of the current is 1 mile per hour. Okay, on the next page, number 3, Jason purchased 3 pies and 4 drinks for $23. Julie purchased 2 pies and 5 drinks for $20. Find the cost for each pie and each drink. Well, you can use any variables you want. I'll pick X to be the cost of a pie. And I'll use Y to be the cost of a drink. And Jason, he purchased 3 pies and 4 drinks for $23. So the equation we get for Jason is 3x plus 4y equals 23. Julie purchased 2 pies and 5 drinks for $20. So for Julie, 2 pies cost 2 times x dollars, 5 drinks is 5 times y, and a total of 20. So we get a system of 2 linear equations. So on the top equation, I'll multiply both sides by 2. And on the bottom equation, I'll multiply both sides by -3. So on the top equation, multiply both sides by 2, we get 6x plus 8y equals 46. Multiply every term on both sides of the bottom equation by -3, I get -6x minus 15y equals -60. When we add these two equations together, the x eliminates 8y plus -15y is -7y. 46 plus -60 is -14. Divide both sides by -7, we get y equals 2. And then we can use any one of the equations to find x. I'll use this equation right here. So on this equation, replace y with 2. So 2x plus 5 times 2 is 20. This is 10, so we subtract 10 from both sides. We get 2x equals 10. Divide both sides by 2, we get x equals 5. Okay, so $5 is the cost of a pie, and $2 is the cost of a drink. Okay, let's move on to the next problem, number 4. Jackson invested $32,000, part of it at an annual interest rate of 6%, and the rest at the annual interest rate of 8%. After 1 year, he received $2,060 in interest. Find the amount of money that was invested at each interest rate. Okay, so I'll pick x to be the number of dollars at the 6% annual interest rate, and I'll pick y to be the number of dollars invested at 8%. Okay, so the total amount invested is $32,000, so that means x plus y is $32,000. And then for interest, the amount of interest that X dollars earns is 0.06 times X. The amount of interest Y dollars earns is 0.08 times Y. And we're given that the total amount of interest is $2,060. So if you want to get rid of the decimals on the bottom equation, you can multiply every term on both sides by 100. So we get 6x plus 8y equals 206,000. So I'll rewrite that over here. Multiply both sides by 100, we get 6x plus 8y equals 206,000. Okay, so to solve, we can multiply every term on both sides of the top equation by -6. So multiply by -6. And then we'll get -6x minus 6y equals -6 times 32,000. And when we add those together, the x variable eliminates. 8y plus -6y is 2y. And here we get 206,000 minus 192,000 when you multiply -6 times 32,000. And 206,000 minus 192,000 is 14,000. So 2y is 14,000. Divide both sides by 2, y is 7,000. And to find x, we can use this equation. So x plus y is x plus 7,000 equals 32,000. Subtract 7,000, we get x equals 25,000. Okay, so $25,000 is invested at 6%. And y equals $7,000 is invested at 8%. Okay, the next problem is a mixture problem. 100 liters of a 6% acid solution is needed. Find the number of liters of a 5% acid solution and a 10% acid solution that are needed. Okay, so we're going to assign variables for two quantities. Let x be the number of liters of the 5% acid solution, and pick y to be the number of liters of the 10% acid solution. Altogether, we need 100 liters, so x plus y is equal to 100. And the mixture has to be 6%. So we, in the second equation, multiply x by 0.05 times x, and multiply y by 0.10. And then the mixture has to be 6%, so that means we're going to multiply 100 by 0.06. Okay, if you want, you can get rid of the decimals. If you multiply every term on both sides of the bottom equation by 100, we get 5x plus 10y equals 600. And I think what I would do is, I'm going to use the top equation, and then I'm going to divide every term on both sides of the bottom equation by -5. Divide by -5. So our two equations, the top equation, x plus y, is 100. And the bottom equation will be -x minus 2y equals -120. And then when we add these equations, the x is eliminated. Y plus -2y is -y. 100 plus -120 is -20. And so positive y is +20. And then since x plus y is 100, we can see that x equals 80. Okay, so x equals 80 liters of the 5% solution, and y equals 20 liters of the 10% solution. Okay, let's move on to the next page. Okay, so here we simplify expressions with exponents. The one on the upper left, before applying the outer exponent, let's simplify what's on the inside of the parentheses. So the numerator has a constant 6 to the -3. And y to the 4th. So 6 to the -3 in the numerator is equivalent to 6 to the +3 in the denominator. And we also have a factor of 7 in the denominator. And we have x to the 2nd in the denominator. That's the only term with x in it. In the numerator, we have y to the 4th. And in the denominator, we have y to the -7, but that means the same thing as y to the +7 in the numerator. So let's simplify inside the parentheses a little bit more. So in the numerator, y to the 4th times y to the 7th is y to the 11th, because we're adding the exponents. In the denominator, we have 6 to the 3rd. 6 times 6 times 6 is 216. And then times 7 times x to the 2nd. So since I don't have a calculator and you're allowed to use one, I'll leave the multiplying 216 times 7 to you. The last thing we want to do is apply the outer exponent. So in the numerator, we get y to the 22nd, because we're multiplying the exponents. And in the denominator, you can square 216 and multiply that by 7 squared, and then x to the 4th. But like I said, I'll leave the numerical part here for you to do with a calculator. Okay, the next problem. This time we have an outer exponent that's -3, but before applying the outer exponent of -3, let's simplify on the inside of the parentheses first. In the numerator, we have a factor of 5, and in the denominator, we have a factor of 2. And now let's turn our attention to the variable x. In the numerator, we have x to the 5th. In the denominator, x to the -2 is equivalent to x to the +2 in the numerator. And then we have y to the 1st in the numerator and y to the 6th in the denominator. So that simplifies to y to the 5th in the denominator. Okay, in the numerator, we'll simplify a little bit more. 5x to the 5th, x to the 2nd is 5x to the 7th. And the denominator is 2y to the 5th. Okay, now, since the outer exponent is -3, we reciprocate the fraction. So in the numerator, we'll have 2y to the 5th. In the denominator, 5x to the 7th. And then change the outer exponent to +3. Okay, and now we can apply the outer exponent. So we're going to get 2 to the 3rd times y to the 15th, because 3 times 5 is 15. And in the denominator, we have 5 to the 3rd times x to the 21st, because 3 times 7 is 21. And then we simplify the numerical parts. 2 to the 3rd, 2 times 2 times 2 is 8. So the numerator is 8y to the 15th. And in the denominator, 5 to the 3rd is 125. So our final answer is 8y to the 15th divided by 125x to the 21st. Okay, the next part, we're just multiplying polynomials. So here we have two binomials. So first multiply 5u times the binomial 2u plus 3v. So 5u times 2u is 10u to the 2nd. And then plus 5u times 3v is plus 15uv. And then we subtract 4v times 2u is minus 8uv. And then finally we subtract 4v times 3v, or minus 12v to the 2nd. The two middle terms are like terms, so we simplify those. So we get a total of 10u to the 2nd plus 7uv minus 12v to the 2nd. Okay, and the next problem, here we're multiplying a binomial and a trinomial. So first multiply x in the binomial by every term in the trinomial. So x times x squared is x to the 3rd. And then minus x times 6x is minus 6x to the 2nd. And then minus x times 7 is minus 7x. Then we switch to -5, multiply -5 times every term in the trinomial. We get minus 5x to the 2nd plus 30x and plus 35. And then the last thing, combine like terms. There's only one x to the 3rd term. We have minus 6x squared minus 5x squared, which is a total of minus 11x squared. Minus 7x plus 30x is plus 23x. And then plus 35. This is as far as we can simplify that. Okay, the next one, the binomial 3m minus 7n squared. Well, when you square something, that means to multiply it by itself. So we're going to multiply 3m minus 7n times 3m minus 7n. And 3m times 3m is 9m to the second. And then minus 3m times 7n is minus 21mn. And then we multiply negative 7n times the binomial. Negative 7n times 3m is also minus 21mn. And then negative 7n times negative 7n is positive 49n to the second. And combine like terms. The two middle terms combine to give us minus 42mn. So the trinomial, this is a perfect square trinomial, 9m to the second minus 42mn plus 49n to the second. Okay, the next one, we're also squaring a binomial. This time square 6r plus 5t. So when you square something, that means to multiply it by itself. So 6r plus 5t times 6r plus 5t. Okay, 6r times 6r is 36r to the second. And then plus 6r times 5t is plus 30rt. And then plus 5t times 6r is plus 30rt. And then finally, plus 5t times 5t is plus 25t to the second. The two middle terms are like terms that can be combined by adding. So we get the final result, 36r to the second plus 60rt plus 25t to the second. And now we do the reverse process of multiplying. So factor each polynomial. This first one, 49y to the second minus 84y plus 36. The greatest common factor of all three terms is 1. So since the term on the left is a perfect square, 49y to the second is a perfect square, and the term on the right, 36, is also a perfect square. Let's check to see if it's a perfect square trinomial. So 49y to the second is the same as squaring the term 7y. And 36 is the same as squaring 6. So 6 squared. So we want to know if the middle term is minus 2 times 7y times 6. And sure enough, 2 times 7y times 6 is minus 84y. So it is a perfect square trinomial. That means its two factors are 7y minus 6 and 7y minus 6. Okay, the next one, a to the second plus 25ab plus 46b to the second. The greatest common factor of all three terms is 1. Well, this can't be a perfect square trinomial because 46 is not a perfect square. So we'll try the AC method. The coefficient of a squared is 1. Multiply that by 46, the coefficient of b to the second. And we're looking for two integers that have a product of positive 46 and a sum of 25. Okay, it doesn't take too long to find. In fact, the next pair of integers after 1 times 46 is 2 times 23. And 2 plus 23 is 25. So the two integers are 2 and 23. So we transform the trinomial into a quadrinomial. We'll write a to the second plus 2ab plus 23ab plus 46b to the second, and then factor by grouping. Out of the first two terms, we can factor out a, and the binomial is a plus 2b. Bring down the middle operator of addition, and out of the third and fourth terms, the greatest common factor is 23b. And the binomial is a plus 2b. At any stage, you can check by multiplying that you're factoring correctly. Okay, but then the last step, factor out a plus 2b. And the other factor is a plus 23b. Okay, the next one, 81c to the second minus 64k to the second. This is a difference of squares, so we can rewrite 81c to the second as squaring the term 9c. And 64k to the second, we can rewrite that as 8k to the second. And then the difference of squares, one factor is 9c minus 8k. The other factor is 9c plus 8k. And check by multiplying if you are in doubt. Okay, the next one, a sum of squares. We need numbers that are non-real numbers to factor a sum of squares. So we'll just say not factorable with real coefficients that are real numbers. Okay, on the next page, we continue the factoring. Okay, the one on the upper left, 27x to the third minus 8y to the third. This is a difference of cubes, 27x to the third. We can rewrite that as the term 3x to the third. And minus 8y to the third, we can write that as minus the term 2y to the third. And then apply the difference of cubes factoring formula. I'll rewrite that up here, a to the third minus b to the third. The binomial a minus b is a factor, and then the trinomial a to the second plus ab plus b to the second. Okay, so here we have a binomial factor, 3x minus 2y. And then in the trinomial, the first term, we square 3x. And then we add 3x times 2x. And then we add, 3x times 2y. And then we add what we get when we square 2y. And then we'll simplify that, 3x minus 2y. And then in the trinomial, when we square 3x, we get 9x to the second. And when we add 3x times 2y, we get plus 6xy. And then when we square 2y, we get 4y to the second. Okay, the one on the right is a sum of cubes. So we can rewrite this as the term 4m to the third and replace 125n to the third with the term 5n to the third. The sum of cubes factoring formula, a to the third plus b to the third. The binomial factor is a plus b. And then the trinomial is a to the second minus ab plus b to the second. Okay, so our binomial factor is 4m plus 5n. In the trinomial, the first term, we square the term 4m. Then we subtract 4m times 5n, and then we add what we get when we square 5n. Okay, then in the next line, we just simplify what's in the trinomial. When we square 4m, we get 16m to the second. And then we subtract 4m times 5n, we subtract 20mn. And then we add 25n to the second. Okay, the next one, 81u to the second plus 144uv plus 64v to the second. The greatest common factor is 1. So maybe you've noticed when coefficients are large, such as in this case, the coefficients are pretty big. Usually it turns out to be a special factorization. You can use the AC method, but the numbers are pretty big. 81 times 64, we could figure that out, but look for something that's a little more special, shall we say. The term on the left is a perfect square. 81u to the second is a perfect square. The term on the right is a perfect square. So we should wonder if it's a perfect square trinomial. So 81u to the second, that's the same as 9u, the term 9u squared. And the third term, 64v to the second, is the same as squaring the term 8v. So to check to see if it's a perfect square trinomial, the middle term would have to be plus 2 times 9u times 8v. 9u times 8v is 72uv, and 2 times 72uv is 144uv. So it is a perfect square trinomial. That means its two factors are 9u plus 8v times 9u plus 8v. Okay, the next one, 3x squared minus 48x plus 169, or 189, I mean. The greatest common factor is 3, so we want to factor 3 out first. And we get 3 times the trinomial x squared minus 16x plus 63. And then we want to see if we can factor x squared minus 16x plus 63. So let's do that over here a little bit lower, x squared minus 16x plus 63. Use the AC method. 1 times 63 is 63. So two integers that have a product of 63 and a sum of negative 16. Well, both must be negative if the product is positive and the sum is negative. So it looks like negative 7 and negative 9. Negative 7 times negative 9 is positive 63. And when you add them, you get negative 16. So we can factor further. So replace the trinomial with a quadrinomial, and we can write x squared minus 7x minus 9x plus 63. Then factor by grouping. Out of the first two terms, factor out x. So we get x times x minus 7. Bring down the middle operator of subtraction. Bring down subtraction, and then factor negative 9 out of the third and fourth terms. So we get minus 9 times x minus 7. And the two factors of the trinomial are x minus 7 and x minus 9. Okay, but up here our complete factorization has to include the factor 3. So 3 times x minus 7 times x minus 9. Okay, the next example, x squared plus 7x plus 9, factor this. The greatest common factor is 1, so let's try the AC method. 1 times 9 is 9. Find two integers that have a product of positive 9 and a sum of positive 7. Well, both must be positive. At the extremes, we have 1 times 9. Those add up to 10. The next pair of integers to test, 3 times 3 is 9, but 3 plus 3 is 6. And there's no other pair of integers to test. So this means that x squared plus 7x plus 9 cannot be factored with integer coefficients. So this is not factorable with integer coefficients. It is factorable, just not with integer coefficients. So in this class, that's where we stop. Okay, the next one is a quadrinomial. 15pq minus 15p plus 12q minus 12. So we can try to factor by grouping. But first, the greatest common factor of all 4 terms is 3. So we'll factor 3 out first. And we get 3 times the quantity 5pq minus 5p plus 4q minus 4. Then we'll try to factor by grouping on the inside of the parentheses. So out of the first two terms, 5pq minus 5p, the greatest common factor is 5p. And when we factor 5p out of both, we get q minus 1. Bring down the middle operator of addition. And then out of the third and fourth terms, factor out the greatest common factor, 4. And we're left with q minus 1. And then the complete factorization is 3 times q minus 1 times 5p plus 4. Okay, we have less than a minute left, so I guess we will go ahead and stop there. And tomorrow we'll start with problem number 9 on solving equations by factoring. So go ahead and sign in for attendance.
Sounds good.